We'll start the recording. Yes, so today I want to present how to train with TPU and Pytorch. So on a TPU, as mentioned, you have different cores, and we need to distribute the computation on the cores. However, for a specialty about TPUs in contrast to GPU, is that the computation graph is first compiled and optimized. And this computation or this compilation and optimization step is quite slow. So you have to ensure that the forward pass and the backward pass is the same for every batch you run. Hence, you have to use padding to a fixed length, and you cannot do dynamic padding of your data. So, so maybe someone has already worked with some distributed training in Pytorch. So the traditional setup is you have some data and then you have different workers. So we have 8 different TPU cores. So we create 8 different workers. So every worker is one process running on the machine. And then the worker sends the data to the core computes the forward pass, then you compute your loss, and then you do the backward pass. And this is quite easy when you have, like I said, traditional data, when you have some classification tasks. So you have input 1, some document and some label, and then the document 2. So you have some document and some label. And so that's the traditional setup. And how you do it in Pytorch typically is you split your data set into 8 smaller subsets. So I don't know, when you have 100,000 text documents with a label, I don't know, when you do sentiment classification, for example, you split it up into 8 equal subsets, and then every worker is accessing one subset of this data. And also every worker is shuffling and generating the batches. If you train embedding models, it becomes sadly a bit more challenging than the traditional distributed training setup. So we train with multiple negative ranking loss. So what we have some examples where we have a question and an answer, and we use the other data points as negatives in the batch. And given a question, so for example, when we train on question answer data, the task is given a question, which of these answers is the correct one? When we have a batch size of 64, we use 64 answer candidates. So for a question, we have to find the correct answer out of 64 candidates. However, when we use batch size of 4K, we have 4K answer candidates. So given a question, which of these 4K answer candidates is the correct one? And it has been shown that the larger the batch, the better the performance. So because it's a lot harder to find the right answer out of 4K answers than out of 64 answers. However, the memory is limited on the individual cores. So we have, I think, 16 gigabytes on a TPU per core. And it's not possible to run I don't know, a batch size of 1K on a single core. So what we need instead is cross-device communication. So how does cross-device communication look like? So we have our different slices of the data. We send the data to the 8 individual processes. Every process is sending the data to one core, and the individual cores, they compute the embeddings. What's now special about this is that we have to gather all the embeddings in a central place. So instead of having, I don't know, 64 embeddings on every core, we gather all the embeddings on one place so that we have in total 512 embeddings at one place. And then we use this one place to do the loss computation and also do the backward communication. So this is how we increase the batch size from 64. So we have on every core batch size of 64 to a total batch size of 512. So the global batch size becomes 8 times larger for the 8 cores, and the difficulty of the task is 8 times higher. And we see that we get quite nice improvement in performance. So here we see when we go, I don't know, for example, from 128 to a batch size of 1K, you get quite a big improvement by simply increasing the batch size. So the cross-device communication is quite easy to implement in PyTorch. So this is one special thing which you will not find in other examples of TPU training or distributed training with PyTorch, but which is quite relevant here. So the implementation is as the following. So we have our two texts. So we have for example, the questions and we have the answers. We pass them through the tokenizers. As mentioned, for TPU, it's important to have a static computation graph. So here, the padding, we have to pad to the max length so that every text batch is like 128 word pieces. Even when, I don't know, for questions, they are usually quite short. So, so you still have to pad to 128. Of course, you can use any other length, max length value you want to. Then you can compute the embeddings. So you pass the two texts to your model, to your text model. So the text model does a forward pass through a transformer network, and then it does a simple mean pooling and normalization. And this gives you the embedding for A and the embedding for B. So what's now special is the all-gather communication. So far, when every core is working with a batch size of 64, now you collect all the embeddings from all the cores together. So you get embedding, which is 8 times larger. And then you do the computation on these embeddings. So here, instead of having like batches of 64, you have now batches of 512, and then you do compute the similarity scores. So here we have compute the dot product, which is the same as cosine similarity because our embeddings are normalized to unit length. And you multiply it by some scaling value. So the default value is 20. And then you do a cross-entropy loss. So we compute the cross-entropy loss. And we do a symmetric. So we, as similar as in the clip paper, you take the scores, check so for every question, which of the 512 answers is the correct one. And we do a symmetric also for a given answer, which of the 512 questions is the matching question. So this is the cross-device communication is rather easy to implement with PyTorch. You just need to add like these 2 lines in your code, but they are quite important to get a good performance.
Question: is this because I'm just trying to grasp what is happening here? So this just gathers all the batches together to make a bigger batch, but is this also a way to so in this Rocket QA paper they talk about out of batch negatives. Is that also in here or?
Yeah. So so this is just the symmetric case. So in the code I linked, so in the repository, you can find the code in the repository. Mm-hmm. So this is the case where we have like pairs, an anchor and positive. Mm-hmm. But we can also do as an anchor, positive, and a negative. So where we train with triplets. And there the code is really similar. So we first do tokenization on all the anchors, on all the positives and all the negatives. And then we compute the embeddings. So we compute embedding A, embedding B1, and embedding B2. Then we do all the gaithers. So this is all the embedding for the anchors. These are all the embeddings for the positives. And these are the embeddings for all the negatives. And then we concatenate them together. So, so instead of like having like a batch of 512, we have now 500 positive, 500 anchors, 500 positive, and 512 negatives. We compute these similarities. So this gives us a 500 times 1024 matrix, score matrix. And we set again our labels. So we know for the first example, the first answer is relevant. For the second answer is relevant. And then we do cross-entropy loss. So in this case, I used the one-way loss. Because here you have like not a symmetric score matrix. So here we have for this case, we have like a 512 times 512 matrix. So here we have 512 times 512. But here we get 512 times 1024 matrix. And you cannot simply transpose them. So it would be a bit more complicated to compute the symmetric cross-entropy loss in this case.
Mm-hmm. Okay.
Did it answer your question?
Yes, but yes.
Okay, great. So yes, so this is easy to implement. There's one thing which can cause a lot of issues. So actually in Torch XLA, there are like two all-gather operations. The one is forwarding the gradient, and the other is not forwarding the gradient. And this is quite hidden in the documentation. So what you have to make sure is that you use the functions.allgather and not the XM model.allgather. The operation is the same, but the gradients are not forwarded by the other function. And this, yeah, took me some time to figure out that I used the wrong function there to do the allgather operation. So the second challenge is that we train on multiple data sets. So we have a long list of data sets, in total like roughly 1 billion training pairs, and how to partition data set efficiently across workers. So in a standard setup where you do some classification tasks, you just split your data up to like 8 different chunks, and then every worker can work on its own chunk. But it's a lot harder when you work on multiple data sets, and also when you work on a lot of data sets. So as mentioned the last time, having good batches is quite important for the performance. So for example, we have questions from all the different stack exchanges from like 140 different stack exchanges, Stack Overflow, Traveling, Cooking, and so on. And when you naively random sample data from them, it could be that in a batch you have a question about Python, a question about some visa traveling, and a question how to cook pasta. And here the batch is quite easy because, like, okay, when you search for the correct answer for Python, you take the one programming answer in the batch. So better batching would look like when you take the data from the same subforum. So for example, you only take question answer pairs from Stack Overflow. So, and then you have just questions, programming questions, and programming answers in your batch. And this becomes a bit harder to coordinate because we have like 8 different workers. Every worker is an independent process. Every worker has like independent chunk of data. And how do you communicate that now all 8 workers take questions from Stack Overflow, or all 8 workers take questions from, I don't know, Traveling subset? So we have some desired properties on the data loading. First of all, text pairs in a batch should come from the same subdata set. So all 512 text pairs should come from Stack Overflow, for example, or from Traveling, or from Cooking. We want to do lazy loading, so we want to load from disk. So we do not want to load all the data sets first into CPU memory, but read it from disk when needed. We have different data set weights. So we have some really small data sets where we have just 10,000 pairs, and then other data sets where we have 100 million pairs. And we want to assign more weights to the large data sets. So we want to use them more frequently for more batches. We have this 2-column and these 3-column format. So we have 2-column format, anchor and positive, and some data sets have anchor, positive, and negative. And we cannot mix 2 and 3 columns. So all workers must get data from either 2 or 3 columns as we share the embeddings across the devices. So we have to ensure that every worker works on either 2-column or on 3-column for one training step.
Question.
Yes.
It doesn't matter where the negative comes from. It can come from any data set or sub data set, or
So for the 3-column format, the negative are actually hard negatives. So the hard negative is similar to the anchor. So when you think about this is like some question about Python, like how do I sort a list in Python? The positive would be the right answer, and the hard negative would be a text about Python, but not answering the question. So the intuition is that the hard negative is really close to the anchor, but does not match the anchor as good as the positive.
Okay.
And training with hard negatives is quite beneficial. So here the black line, so that's for semantic search, we train without hard negatives, so just on a 2-column format where we have a question and answer. And when we add like these hard negatives, so these answers which are similar but do not answer the question, we get quite a big performance improvement by that.
So, Nils, what you're saying is that even when we are selecting the batches, it's better to have more similar anchor positive pairs than just random pairs when selecting from multiple sub-data sets.
Right. So having like a batch like this, where you have like a lot of programming question, would be better than mixing all the data sets together. Because then it just learns, okay, what are questions from Stack Overflow? What are questions from traveling? What are questions from cooking? But it does not learn to differentiate between different questions from Stack Overflow, like, okay, what's a Python question? What's a C question? What's a NumPy question? And so on.
Another question with respect to the hard negatives. The Rocket QA paper considers random negatives, right? So that when we randomly select the cross-batch negative or in-batch negative, how do we make sure that it's a hard negative?
So when you train with the 3-column format, you have a separate mining process for hard negatives.
Okay.
So either you can have, so there are 2 ways. So either you can exploit some structure in the data. So when you think about Stack Overflow, I don't know, let's open Stack Overflow, sort Python. So what we could do is take this as the question, sort a list in Python, and then we take the best answer as the answer. And then we check what is like a really bad answer, for example, and use this as a negative. So we say, okay, we want to have this text closer to the question because it's better than having a question which is like really has like a lot of negative votes.
Okay, I understood. I think it was a wrong question asked. In case of doubles, when you have the pairs, then the automatic negative stuff is random. But when you have triplets, we don't have to worry about this auto in-batch negatives or cross-batch negatives. Is that right?
No.
No. Okay.
So when we train with the 3-column, we still use random in-batch negatives. So we have for the anchor, we have 1 hard negative, and we take all the other positive and hard negatives from all the other examples as random.
So
negatives.
Then it matches the first point. Text pairs in batch should come from the same sub.
Right.
Okay. Yeah.
Right.
Yeah. Thank you.
Okay. So I don't know how much experience you have in multiprocessing with Python. One tool I found quite interesting and useful are queues in Python. So the Python and the Pytorch package has a package which is called multiprocessing. So Torch multiprocessing. It's just a wrapper around Python multiprocessing package. And what we want is we need some communication between the different processes we have. And one pattern which is quite common is like a producer-consumer pattern. So you have one process or one thread which produces things. So in our case, it produces data. it writes them to a first in, first out queue. And then you have different consumers which can consume data from the queue. And the queues can be used to do the multi-process communication. So we can have a producer that's producing the data, which reads the data from disk, for example. And then we have our different worker, which consumes the data from the queue. The producer can either be a thread or a process. And when you initialize a queue, you can pass a max size parameter. So when we look into the code, so here we create a new queue and we say max size is like 100 times the number of processes we have. So you can set some max size, whatever you want for your code. And the interesting or good thing when you work with max size is that the producer blocks until the queue has capacity. So when you say the max size is, I don't know, 1000, you can put 1000 objects on the queue. And then when the producer tries to put another object on the queue, it waits. So it gets idle until there's, again, capacity on the queue. And similar for the consumers, when they get data from the queue and there's no data on the queue because the producer is too slow or the disk is not running fast enough, they also wait until they get the data from the queue. So in the repository, you find two solutions how we can do this multi-data set, lazy loading with different weights. And there's the version 1, which is incomplete, so it only supports the 2-column format, not the 3-column format. And the version 2 is a bit more sophisticated, which I added today, which also supports like all the desired properties we want to have. But I found it interesting to show you like, okay, how can you design this in like different setups? So in the most simple setup, we have 100 different data sets. So these are 100 different files on your disk. And then for every file, you create a queue and you create some producer thread. So the thread is reading from the disk, put it to a queue. And yeah, you do it for all the data sets you have. So then you have your 8 different workers which communicate with the TPU cores. So they randomly select a queue and then they pull per device batch size examples. So for example, they pull 64 examples from the queue and they use this 64 examples from the same queue to do the computation. What we want, as mentioned on the global batch size, we want to have all the data from the same data sets. So we want to have like not 64 examples from Stack Overflow, but we want to have like 512 examples from Stack Overflow. So what you can do is you can fix the random number generator. So you initialize every worker with the same random number generator. And then in every compute step, they will select randomly the same queue and get the same or get data from the same data source. So that's one solution. The second solution, which I recommend to use because it now completes, it fulfills all the properties we have. So there we have just one queue and we have one producer, and the producer has file handles open for all the 100 different documents we have for the different data sets we have. And the producer is randomly selecting the data sets here and is reading from disk the data sets and then puts data on the queue. So on the queue, we, instead of putting individual examples, we put like full batch examples. So every item on the queue contains 64 examples. And what we have to ensure is that certain number of consecutive batches are from the same data set. So we want that all the workers get data from the same data set, for example. So we put 8 times, for example, Stack Overflow on the queue. And then we know our 8 workers will pull 8 times a batch from the queue. So all the 8 workers will work on Stack Overflow data. We can also split it. So sometimes it can make sense to say, okay, I do not want to have like all the 8 batches from Stack Overflow, but I want to have 4 batches from Stack Overflow and 4 batches from, I don't know, Ask Ubuntu, for example. So you can put like 4 times Stack Overflow and then 4 times Ask Ubuntu on your queue. However, we have like this 2-column and 3-column format. So we have to ensure that the worker, that all the workers get the same format. So when we cannot mix the format between the workers. So we have to ensure that all these 8 mini batches are all of the same format in either 2 or 3-column format. So it's a bit more complicated, the setup, to understand, I could imagine. But it's yeah, hopefully not too complicated.
What's the benefit of the other solution? Because to me, this seems much simpler than the other solution.
So this is simpler than this solution?
Or am I just simplifying it in my head? Maybe that's it. But
yeah, I found this easier to implement because here you just have queues. Mm-hmm. So here you just have like queue, and you know this queue is from document 1 and this queue is from document 100. And then the responsibility is on the worker, where you just pull.
But you still need to orchestrate the workers to get from the same queue. And is of course some risk involved in there. And also how random is it? And if you want to actually take one data set more than the others, you have to build that inside the worker. While you can, in the other side, you can much easier orchestrate it with one producer.
Yeah, it's still quite easy. Was still quite easy to implement it in the worker side. So here you said just ensure you select the same random number object, random number generator with the same seed, and then you know they pull from the same queue.
And but then they randomly select one, but you don't have implemented which data set they should take more often than others, right?
Yeah, you do this by sampling with weights. So instead of randomly sampling 1 out of 100, you assign every queue some weight. And then this has, I don't know, 10% probability to be selected, and this has 1% probability to be selected. And so it was quite easy to implement. Took me longer to implement this, also to ensure like this, that you can have like a mixture of batches of data sets, so that you have like half of the data on Stack Overflow and other half on Ask Ubuntu, and you are not allowed to mix like these 2 formats.
One question with respect to the triples. If we want the negatives to be hard negatives, then the data set should purely be about Python, right? For example.
Right. So here's a question about Python, the correct answer and the hard answer about Python. I mean, you could control and try to only include Python questions into your data set. That would also be fine.
Okay.
But at some point, it can get like really tricky to create these batches. But of course, now we have like this single process which can control like which batches to generate. So you could also say, okay, I do not put like, I don't know, 512 examples from Python, but just 64 examples from Python in my queue. And then one worker will only have Python questions, the other worker will only have Java questions, the third worker will only have, I don't know, NumPy questions. So you can get like really creative. And yeah, how you construct your batches is quite important.
Yeah, but if the okay, one worker will have Python, one worker will have NumPy, but then what about the cross-batch negatives? So don't we have to make sure that every worker will end up with this same in case of triples to promote cross-batch negatives?
I mean, in terms of triples, All the positives and all the hard negatives of all the other examples are also communicated. So when you train with triples, you have the one anchor, which will match with like one of the positives. So 1 out of 512 positives. And then there are like 512 additional negatives, which you will distinguish to. So when you have like, let's say batch size is 512, then you have question, find answer to a question out of positives plus 512 negatives. So in this case, you do not check what is the correct answer out of 512 possible candidates, but out of 1024 candidates.
Yeah, okay.
And you just assume that the negatives from other questions are also negatives for your question.
Okay, okay. Yeah, okay, yeah, thanks.
Okay, so now I want to give like short code overview. And then after that, I will show you how you can train on the TPU and some things I already set up. So yeah, this is the training code. I think it's not too long, so it's just 300 lines of code. There are some parameters you can set, which is the model name you want to train, the number of steps you want to train on. So the default is like 2000, which is like really little, but it's good for testing. So after 2000 training steps, you already get quite some good performance. Save steps is like after how many steps you want to save the model. So here we save after every 10,000 steps and also after the model finished the training. As mentioned, it can happen that the TPUs are crashing in between, so it's good to select some sensible save steps value. The batch size is the batch size per core. So the default value of 32, so every core gets a batch of 32. And then the global batch is 8 times 32, so in total 256. It depends the batch size, how large can you select the batch size depends on the model. So when you use like a small model, like the mini LM layer 6 with 6 layers, that's a really small model. You can increase the batch size. When you train with some large model, BERT large, Roberta large, you might have to reduce the batch size. So, so it's always depends on the how much memory every core has. So every core has 16 gigabytes of memory. So you have to check how many examples you can squeeze into one core. Datasets per batch. So we have the global batch, and then we want to mix it with two datasets. So when you set it to 1, then we ensure that all 8 workers get data from all the same data set. When you set it to 2, then half of the workers get from, I don't know, Stack Overflow, the other half from Ask Ubuntu, for example. If you set it to 4, then there are in total like 4 different data sets in the batch. The scale is related to the loss. So it could also be interesting to play around with the scale parameter. It can have quite some impact. And there's a data folder. So on every TPU, I mounted a folder under the root data where all the data sets are. So when you look on the machine, we see here all the data sets we have in which you can use. And then you pass a data config file and an output folder. So how does a data config file look like? So the data config file is a simple file where you specify on which data sets you want to train. So it checks the data folder. And then in this case, I want to train on this data set, and this data set. And you can pass some integer weight value. So here we pass the weight 100. So all the data sets will have the same weight. You can also do a weighting. So here we have all the data sets, and then we see here we have a weight 1. So all these data sets are sampled with a weight of 1. And then the larger the data sets get. So wiki answers, we have 77 million examples, it gets sampled with a weight of 54, so it's 54 times more likely to be sampled than the small data sets. And yeah, that's how you can create like your data sets. So you can choose like the data sets we have, you specify which data sets you want to use, and you pass this configuration to the training script. And of course, you also pass an output folder. So then we create the queue. So we use this queue between the producer and the consumer. And we create some arguments for the producer where we say, okay, this is the queue, these are all the file paths, and these are all the dataset indices. So this contains the weight. And then we start the process to produce the data. And then we start the process for training. And how does producing data look like? So every data set we wrap in a dataset class. So we have all the file path and we wrap it in a dataset class. So the dataset class is like a really simple dataset class. It reads the lines from the file path. It decodes the JSON. It extracts the text column. And then it yields the dataset. Because we have small data sets, it can happen that we run out of data. So, and there could be like two solutions. You could just start over, open again the file, read the file line by line. Well, what I did here is I added all the lines to a variable data set. And then I have just an infinite loop, which randomly shuffles the data sets and then runs over the data sets and yields the data. So we have one dataset class for every dataset file. You could also create your own dataset classes. So if you have more complex data from, I don't know, Reddit, for example, where we have like multiple contexts and so on, and you want to test different approaches to use only one context or two contexts or three contexts or shuffle between them, you could create like a custom Reddit dataset class. And then here you just have to yield like the 2 or 3 column format. And you can do in the code like some mixing between one context, two contexts, three contexts, and so on. Yeah, in the producer, we store the information if it's like a 2 column or 3 column format. As mentioned, we cannot mix it between the workers. So all workers have to work on either 2 or 3 columns. And then we start our infinite loop. So the producers will just be producing. We ensure that there are no duplicate text in a batch. So we define a set where we have all the text in a batch. We define what is our batch format. So is it 2 column or 3 columns? And then we randomly select a data set. We ensure that it has the correct format so that all the data sets we select have like 2 column format or 3 column format. And then we get the data from this specific data set. So we have some batch device variables. So this is the batch for one device. And then we get the data, the number of examples so that one worker can work with it, and we put it in our queue.
Is it true for the TPU, because you can't change the batch size, so that when you're training with the 2 column format, you're you're only training on the 2 column, and when you're training on the 3 column, you're only training on the 3 column, because when you change, the TPU have to recompile. Is that true?
And no, you can mix it. So here we see, so this is a training function. We have the tokenizer and the model. So the model is really simple, where we do the forward pass. So the model computes the model output, and we do mean pooling, and we do some normalization of the parameters. So the train function looks the following. So we first get the device on which TPU core we compute. Then we set up our optimizer, Adam. We set up the learning rate, the scheduler, our cross-entropy loss. And then we get No, we don't need that. We train for the number of steps we have defined as parameter, and here we get from the queue the data set. And we check here if it has a 2-column format or a 3-column format. And then we do like different operations on the loss. So here for 2-column format, we compute the one way, or in this way the loss, and for the 3-column format in different way of the loss. We can mix the batches. So we can have like first train on 2, 2, 2, like so 8 times 8, and then the next batch we can train on like 3-column format. So we have all the data sets for all the 8 cores have to be 3 columns, and then we can again like do 2-column format.
So the TPU doesn't have to recompile to do this. This graph which you said in the beginning.
Yeah. So here it has to do compile for 2-column format.
Mm-hmm.
And when it first encounters the 3-column format, it has to compile for the 3-column format. But then here it uses the cached version. So it's using what was computed here, it's cached. So these 2 steps will be really slow. It will take a lot of time. And these steps will be really fast. So usually when you start, it takes a few minutes until everything is compiled and optimized, and then it's quite quick.
Cool. Clear.
Okay, so that's the overview of the code. Any further questions on the code?
So the train function does like every computation related to batch, right? It's not only doing the inference, it's doing everything.
Yeah, the train function does everything. So computes the embedding, it shares the embeddings across all the devices, computes the dot product, which is equivalent to cosine similarity when you have normalized embeddings, computes the cross-entropy loss. And then we do the loss backward. So we do backward pass, we do gradient clipping. And then we have to use like the special XM optimizer step, and then does a learning rate scheduler. And we check if we save the model or need to save the model. So that's the train function.
Yeah. The reason I asked is that there's like single device used across the method, but we are the getter is required. The device object is just one object, so it's single TPU core. Is it?
Not sure what you mean. So we have this train function, and this train function is replicated 8 times for every device we have. So there are 8 different workers, 8 different processes, and every process is running this train function.
Yeah, I was just curious about the functionality of the getter function. Because if we are using like one single core, yeah. I was wondering why this was needed.
Oh yeah, when you use just one core, then this all gather is not needed. So this function is just needed when you work on 8 cores.
I see. Yeah, thank you.
Great. Okay. So yeah, so we have here our list of TPU names. So in the documentation, in the Hugging Face repository, you find like a setup how to access the TPU cores. So basically what you have to do is you have to install gcloud. So you install gcloud, and then you say which TPU you want to use. So here you specify the name, and then you connect to that GPU. And then you're on the TPU. So I renamed the host name to show, okay, this is TPU 4. So they all have numbers. So between 1 and 5. And then, as mentioned, in data, you find all the data sets we have. And then they will, when you connect, it will create a user for your name. So here we have, it's connected by Niels. And then what I did is I checked the repository. So that's the repository. So you can just git clone the repository. This gives you all the data sets you want. And then it can make sense, or you have to install PyTorch and PyTorch XLA. So I personally work with Conda. So I first installed mini Conda, and then I created a new environment which I call PyTorch, and you install PyTorch, you install PyTorch XLA, and then you install sentence transformers. What you need to do is, before you can train, you have to tell PyTorch where's the TPU at which address. So you have to export this environment variable. And then you can do multi-dataset training. So you can also use the multi-dataset training script to just train on one file. So you call the function, the script, you pass your JSON file with the configuration, which datasets you want to use, and you specify the output folder. So for example, this is like the script or the command I'm using. You call the version 2 script. You specify for how many steps you want to train. You specify what's your batch size on a single core. You specify which model you want to use. So you can use any model which is compatible with PyTorch auto model. And then you specify the configuration, dataset configuration you want to use, and you specify the output folder, and then it starts training. So I can just show you. So here we use all datasets version 2. No. And then, so that's some. Yeah, here they are complaining some datasets are missing. I have to fix it, but in principle, that's the way you can train. Yes, so the GPU can only be used by one person. So it would be good if you could put your information here and who's using it, what are you doing, and what's like the estimated time until you're finished. And then on a TPU itself, it will give you some errors when you try to start another process. And you can always check htop if the machine is ready, is empty. So for example, here the machine is empty. We see no processes running. On this machine, I have currently a process running, and you see like, okay, a lot of CPU utilization. So here you see currently a training process is running. That's from my side. Do you have any questions? Need any further help?
Maybe, Niels, a quick question on how many times does it take to maybe to train a model on a full data set, for example, on the 1 billion sentences? You have a figure in mind?
I did not test the full data set. So this is a really small model. And for 10,000 steps, it takes like 25 minutes, like 20 minutes, roughly. So 10,000 steps, 5 times 512, that's 5 million data pairs. So if you want to train on the 1 billion, it takes some more time. So, okay. So currently I'm training with like 100,000 steps. So doing some testing. So this takes like, I don't know, like 3-4 hours. If you increase the model, of course, it takes longer. So if you train a base model, this takes longer. If you train a large model, this takes even longer. And currently I'm doing some tests where I tested like different models with different setups. So the best model I currently have is a Roberta large model with 80K steps. After that, the TPU crashed, sadly. This works quite well. And here I have a model trained with where I combine like 2 data sets in the same batch. And here I combined 8 data sets in the same set. And that's the same batch. And you see, okay, reducing the data sets to 2 and not using 8 and gave some nice improvement on the different benchmark data sets I have. And of course, larger models perform better than the still Roberta and performs better than a mini LM model. So here you have the traditional speed performance trade-off.
Can we also cover the like benchmark script that you created? I found that's probably very useful.
Yeah, I will create. We'll create like a nice clean version. Until then, it's in the flex sentence embedding script. I thought it's here. No. Yeah, I will create like a version somehow. Oh, yeah. Here it is. I will create a nice version out of it. If you're impatient, you can go to the flex sentence embedding repository, switch to the branch Niels development, and then there's the embedding benchmark thing. But I will create like a nice repository which you can use and which I will communicate on the general channel where you can find it. And yet it's tested models on different data sets. So from 20 news groups, here we have emails, we have Ask Ubuntu duplicate questions. Biosys is from medical domain. And then some data from Stack Exchange, Piora, and so on. Just have to be a bit careful because there's a train test overlap. So here Ask Ubuntu and CQA Dubstack are both from Stack Exchange, and the data also appears in the training data when you use the Stack Exchange data sets. So if you train on it, you'll get like quite good performances on these data sets, for example.
But can we do the same for the multilingual model as well? Benchmarking across, I think there are around 14, is it? Or 14 to 15, or no, 20 columns, is it?
Yeah, I mean, you could run it, but it just evaluates on English. So sadly, I don't have good evaluation data for other languages or cross-lingual languages.
Okay.
No,
it was just an open question.
Yeah, I mean, as you or people who have been in the channel on multilingual data set have noticed, like really hard to get data for other languages.
Yes.
I mean, it's hard to get training data. It's hard to get evaluation data.
Yes.
But yeah, you can test the model on English. How well does it perform on English, and then hope that it. Yeah. So if you have a multilingual model, not a monolingual model for some other language, then hope that it performs well also for the other languages you have.
I mean, luckily you had some for the multilingual stuff, but not all, of course. But
yeah, I've some for STS, but the STS is like a really you should be careful because it's like really narrow. It's just 1,000 sentences. All the sentences are really simple. So it does not really cover any domain-specific knowledge. So it does not check the model. Does the knowledge have knowledge about computer science, about medicine, about engineering, about, I don't know, online games, about crypto investments, and so on. So there you wouldn't need like really broad data set in, I don't know, in Chinese to test if the model really understands crypto investments in Chinese. And you cannot expect from the STS data set, which has like 1,000 pairs, from really simple English, like some image captions about some dog running in the park. You cannot conclude how well does the model know about all these specialized domains.
Can you share the link to the this spreadsheet as well?
Yeah, we'll create some nice spreadsheet. Also share the link to the spreadsheet.
Thank you.
So yeah, I was wondering, so which type of experiments you would like to run?
Everyone, or is it just a trend?
No, like everyone. Like,
oh, okay.
All the people here in the call, like, so what would you think it would be interesting to train on, which data sets to use, and so on?
At least with the semantic search, we could start with the English data sets.
Yeah.
And I'm not sure if we can train on 1 million. No, sorry, 100 million. What was it? Yeah.
Yeah, for semantic search, what could be interesting is to take just train the Q&A data sets we have, like GOOAQ and MS Marco and so on.
Yeah.
So you could just select these data sets. And what could also be interesting, so far in the code, there are like two things. So we limit the length to 128, which is quite short. So you could also increase this length to like further, so to allow also to find longer passages. So I often use like passages like of 300, for example. And the third thing you can do is, the default setting is to normalize the embeddings, but for semantic search, it can make sense to not normalize the embeddings. So normalize the embeddings makes sense when your data is roughly the same length. So when you want to find like data of the same length, so when you have a short sentence, you want to find another short sentence. But for semantic search, you often have like a short question and want to find a long paragraph. In that case, it can make sense to set the parameter here to false. And when you set it to false, the normalized value, you have also to change the scale, change it from not 20, but 1. So change it to 2.
Oh, okay. Yeah. This was in your first presentation, right?
Right.
The scale factor for the.
Correct.
Yeah.
So I personally, I never tested using scale of 20 with dot product. Might be amazing, it might be totally fail. But setting it to 1 when you use unnormalized embeddings with dot product is a safe bet.
Okay.
And yeah, I think for the conversational data set, it could be interesting to create like some custom Reddit data set where you read the data set. So the Reddit data set looks a bit different. So when we go to data Reddit, so where we see we have like multiple contexts. So here we have like, I don't know, context and context 1. And here we have like sometimes also multiple contexts. So here up to context 8. So this is like the comment to a comment to a comment to a comment to a comment in Reddit. And it could be interesting not to try to convert this to like a 2-column format. You can do it. The other way could also be that you create like a custom Reddit data set and where you create these pairs on the fly while you read it. So you read this JSON format and then you return the context and the context 0 plus context 1, for example.
Okay.
So I I'd be interested in working with Reddit, but your idea is to aggregate somehow, to concatenate, in fact, the contexts that are far from the original context, or to keep them separate?
Yeah, so in conversational, so for Reddit, what we have is like, we have a post, and then we have comment 1, and then a comment to the comment, and then another comment. And for these conversational models, you can have multi-context or single context.
Yeah, as in the article you posted, but conv RT, RT.
And yeah, so single context model would you just look, okay, what is my previous comment? So you take this comment and you try to find this comment. The multi-context model would take all these three examples and try to find the next example, so that you have some history and how to train it. So how to train single context model. You would have pair comment 3 and then comment 2. So that's a single context model. And when you do a multi-context model, you would have your pair look like this, comment 3, and then you do comment 2.
And then comment 1 and 0 before that, right? As a concatenated one. Yeah.
Yeah. 1. We can call this comment 0 to be consistent. So yeah, here the order can be relevant. So you start with the newest, because the text gets truncated on the right. So you want to have the newest information at the beginning, and then the previous information, and then the previous information.
Isn't in the multi-context, is it a free series input, like so it's like a question and a response, and then the previous context. So there are free inputs, right, in general, as in the paper discussed?
I'm not sure. It's a long time that I read the paper.
Okay, yeah, I just read it yesterday. So
okay, yeah, no, I read it like, I don't know, like 1 or 2 years ago.
And Niels, do you think that we could also maybe use the sub comments, like this example, the comment 3 or 2, as some hard negatives?
Yeah, I think they are too similar. I mean, the issue with hard negatives, when you train with hard negatives, it's really hard to train with them, because I don't know, when you have like a format like this, you have to be sure that comment 2 is a good match for comment 3, but comment 1 is not a good match for comment 3. And when you think about Reddit, I think humans cannot differentiate between, okay, what's the structure? So when that's comment 3, human cannot say, okay, was it the response to comment 2 or was it the response to comment 1? And in that case, when a human cannot successfully differentiate between that, you're confusing the model, and performance gets really bad. So I think it's better to just train with these texts. Yeah.
Okay, I think I would try to have a look at the multi-context then.
Shall we look together, Antoine?
Yeah, sure. We have pleasure. Yeah, it will be a great pleasure.
I think what could also be interesting for Reddit, we have the subreddit information. So currently it's all clustered together. So here we have from League of Legends, and we have here from Preamble, whatever that is.
Fire Emblem.
Fire Emblem. And so that's also a game?
Yes.
Okay, and that's here's Ask Reddit. What you could also try is to get a lot of text from the same subreddit into the same batch, so that you, I don't know, like every batch you have just League of Legends, like responses from League of Legends in the same batch, for example. So there you have to get creative, like, okay, how do I load my data set, how to get the subreddits, and how to efficiently do I get just these pairs from League of Legends and ask Reddit and so on.
Yeah, I think there's a lot of subreddits, like 2 million or something, but maybe we can group like video games and or some generic themes if we can make it.
I mean, you could what I did for Stack Exchange. Stack Exchange. So for Stack Exchange, I have the largest stack exchanges, and then all the stack exchanges which were below a certain threshold, I clustered them together in specify small stack exchange. So for Unix and Travel and Pech and Super User and Stats and Stack Overflow, we had like a lot of questions, so more than 10,000. And all others which were smaller, I put into a small stack exchange. So you could also do a similar thing about Reddit, check like what are the most top 100 subreddits, or top 10, 1,000 subreddits, create 1,000 different files for these, and all the other files go into like other Reddit file. So that would be like an easy way to do.
I have a question about like semantic search.
Yeah.
So what will be the action items in this area? Do we have like evaluation script already, for example? Like.
So there was one code written. So our data, our repositories are still quite a mess. Sorry for that. So I sadly can't remember who wrote it, but we have some transform. Let me check. Transforms and state exchange. So Manadai wrote some code. Where he extracts several texts. So we have title and body from Stack Overflow, from Stack Exchange. But we can also have like title and the highest scored answer as a combination. We have title plus body and the highest score answer. And we can also train with these triplets where we say, okay, we have title and body, the highest score answer and the lowest score answer. And yeah, I will try to run it, but anyone else can also try to run it and create this data sets. And for evaluation, you could create like a train test split. So you stake the stack exchanges, for example. And from every stack exchange, you keep some questions. I don't know, from Stack Overflow, you take, I don't know, 10,000 questions from Stack Overflow. And then you check for the query, can I find the correct answer out of my 10K questions from Stack Overflow? So you have a corpus of 10K, and then you check, can I find the answer for given the title or given title and body?
These data sets have already been generated, right? I remember you uploading it on Hugging Face or something.
I uploaded. So I uploaded. So here we have the Stack Exchange XML file. So these are just the XML files from archive.org.
Yeah, yeah.
What I uploaded is the Stack Exchange title and body.
Okay.
So this is just the title and the question body from the user. These combinations, title and highest answer, title body plus highest answer, were not run yet.
Okay.
So.
Yeah, I'd like to work on this too with Deepak, and maybe we can do multilingual as just a side project.
Yeah, sure. No problem.
Right. Any further questions? Yes.
I think so far clear. Yeah.
Okay. Yeah, we'll have not too much availability on the weekend. So I will be mainly most of internet on the weekend, on Saturday and Sunday. So just feel free to use the channel, and we'll be back online on Monday. Also, yeah, feel free to log onto the TPUs and run your scripts. As mentioned, it's always good to communicate if you're currently using the TPU. And then just grab your TPU, which is free, and do your experiments. And
one question, do I need, because you showed it here on the screen, but I don't need any special login details except what is on these sheets, I guess, right? Because I put myself on this list from Patrick, and he said that I should ask you for login details.
Okay. Yes, so in the sheet, when you put your Hugging Face hub name there, Patrick added these to the list, and you should have gotten an email from
I got that.
Google Cloud. And then, yeah, you just use the command. I can post the command here. So you just run this command. You have
check. Yeah.
You have to replace this with the node you want to connect. TPU name, and then your SSH shell should open, and you should connect to the TPU. But yeah, it would be required that Patrick edit your Gmail address so that you can access these nodes.
That's fixed. Yes, it was just this. Okay, perfect.
Hey, Niels, would we be able to share the recording? I joined a little late, actually quite late. I assumed it was 8 o'clock Pacific time, but
I will upload the recording to YouTube without listing, and then share the link in the Discord.
Thank you.
Okay. Great. Then, yeah, looking forward to what you're doing. Have fun with the TPUs. And yeah, regarding the JAX flag script, sadly, it's not running yet. Patrick and Suraj are looking into it, but it appears to be like some deeper issues somewhere in the code. So it's not sure when we will be able to fix it and get a JAX code running. Great.
Thanks a lot, Niels. It was really cool.
Yeah, thank you.